As we start section 3.2, it's important to take a look back at our list of integration techniques. Now you'll see down here in red that 3.2 is all about the idea of using trig identities to help us perform integration. Now, trig identities are actually very similar in effect to just using basic algebra facts. And so there's a big link here between numbers 2 and 5. And we'll see that a lot of times after we do some trig identities, or sometimes before we do some trig identities, it might be important to use some algebra. But we're going to go ahead and start to take a look at what trig identities we really need to be aware of to complete the types of questions that are going to be in this section. So if we take a look here at the notes, you'll see right at the top I have a review, and this is where I'm going to be writing down these different trig identities. So a couple of the trig identities that are very important for us are ones that we've already discussed in some previous sections. Remember, we have this very important kind of basic trig identity, and from here, remember, I can generate two other identities. And it's important, again, to not just have these memorized, but to understand their creation, really kind of save on some memory space. Remember that if I divided everything here by a cosine squared, I could see that I would end up with a tangent squared of x plus a 1, and 1 over a cosine squared would be secant squared. I could also, instead of dividing by a cosine squared up top, divide everything by a sine squared, and that would leave me with 1 plus a cotangent squared of x, and 1 over a sine would give me a cosecant squared. Now I'm going to go ahead and kind of group these identities together here. I'm going to make these a part of a red group of identities. Okay? These are the identities that we typically refer to as the Pythagorean identities. You can see they kind of look very similar to a Pythagorean theorem shape of a squared plus a b squared equals a c squared. And in fact, that's where this first identity even comes from. But these aren't the only identities that are going to be important for us in this section. We're also going to see that there's an identity here for a cosine squared of x, an identity for a sine squared of x, and an identity for a sine of 2x. And each of these is going to be useful as well. Now, while it is possible to get a very simple identity for cosine squared of x from this first red identity, simply by moving the sine squared to the other side, we're going to actually be using a double angle formula identity, which would ultimately tell us that the cosine squared of x is equal to 1/2 1 plus the cosine of 2x. That is, whatever the angle is over here, it gets doubled on this value over here. Now, interestingly, the sine squared identity is going to look almost identical, except I'm going to have a sine and a subtract in there, which is, again, a very easy way to remember this. Otherwise, you'll notice that these are identical. Now, the sine of 2x, you might recall, is equal to the double of sine x times cosine x. And so these identities I'm going to group together in a blue group. And what we're going to see is that there are going to be instances throughout this section where it may be more advantageous to use a red identity or a blue identity. We want to try to get a sense of how I would know maybe which one to use and what are some of the pros and cons of using each of these different types of identities.